Hello guys, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 432, all O1 data structure. Okay. So in this problem we have to design a data structure to store the strings count with the ability to return the strings with minimum and maximum counts. Okay, right? This is what we need to do, right? And we have to implement the all1 class. All1, it is going to just initialize the object of the data structure. Then increment string key. This is going to increment the count of the string key by 1. If key doesn't exist in the data structure, then insert it with the count 1. Okay. Decrement string key. It is going to decrement the count of the string key by 1. If the count of the key is 0, after the decrement, we have to remove it from the data structure. It is guaranteed that key exists in the data structure before the decrement. This is given to us. Okay. Get max key. So this is going to return one of the keys with the maximal count. If no element exists, we have to return an empty string. Get min key. Okay, this is going to return one of the keys with the minimum count. If no element exists, we have to return an empty string. This is the key point for this problem, right? Note that each function must run in O of 1 average time complexity, right? That is why this problem is 432 all 1 of 1 data structure, right? So this is one key point here. So now let's see how we are going to solve this problem. Okay, so we need to create a specialized data structure that efficiently handles the following operations on strings and their associated counts. We have to increase the count of a specified string, we have to decrease the count of a specified string, then we have to retrieve the string with the highest count, and we have to retrieve the string with the lowest count, right? A key requirement is that each of these operations must be performed in constant time of 1 on average. Okay, this is what the question asks, right? So now let's see how we are going to solve problem. So let's say these are the different words that I have: algorithm, lead, code, and learning. Okay, so here this is, let's say this is my doubly linked list. Okay, so in this I have just stored the frequency. So let's say initially the frequency of this algorithm is just 1. Frequency of this lead, initially it is just 3. Frequency of this code, let's say initially it is 4. Frequency of learning, let's say it is initially 5. Okay, then after that I said that just increment the count of lead. So now if I want to increment the count of this lead, then it will become 4, right? Initially it is just 3, now it will become 4. So what I am going to do here, I am just going to increment the count of this 3 with 1, then it will become 4. Then I will check if this 4 is already there or no. Okay, so this node is already there, this 4 node is already there. Then in this particular node I will add this particular key lead. Okay, so here for this 4 I have added this key lead, and once I did that, then after that I check that there is nothing inside this red color box, so I am simply going to remove it. Okay, we will understand it later on, but just see it diagrammatically first. Okay, so I have just removed it, this red color box. So now I am left with one algorithm, and lead and code both are having 4 count, so 4 code lead, and here 5 learning. Okay, then I come along with this operation, decrement learning. Okay, so initially count of this learning is 5, then it will become 4. So if it becomes 4, then I need to go back, I need to see back if there is any node with this particular value 4. Yes, there is one node with this particular value 4. So what I am going to do, in this 4 I am going to add this learning, and I'm just going to remove this box. Okay, so here you see just these two boxes. Okay, this one node and this node 4, right? So this is the key, and this is the strings, set of strings that I have. This is a key and this is a set of strings that I have. Okay, then this is operation that I come along, get min key. So here I'm just going to simply return this output algorithm. Okay, this is output. I returned. Okay, so because this has a minimum frequency. Okay, then I come along this operation, get max key. So out of these three I have, right, code, lead and learning, four. So let's say I have returned this lead. So I think we can return anything. So we can return anything. I didn't mention anything, right? Get returns one of the keys with minimum count. Okay, one of the keys. So we can return anything here, code, lead, learning. So that, let's say I have returned lead here. Okay, so this is what we need to do, right? So now how we are going to solve this? So let's read this. To manage a collection of keys and their frequencies, we need a structure that updates easily and provides quick access to the maximum and minimum frequencies. We start with the hash map to look up each key's frequency quickly. Okay. However, a hash map alone doesn't track frequencies well, right? We need a way to group keys by their frequencies and find keys with the same frequency. So for that purpose, we are going to use a doubly linked list. Each node represents a frequency, right? Each node is going to represent a frequency and holds all the keys linked to that frequency. This setup allows us to add and remove keys efficiently as their frequencies change. Okay, so I am going to use this hash map, and hash map is nothing but going to be a string integer format, right? String is going to be my key and count is going to be my integers, right, values. And we are also going to use doubly linked list. To handle edge cases better, we include dummy head initially and tail node in the list. Okay, these nodes make it easier to manage operations when the list is empty or when we add or remove nodes at the ends. Okay, so this, to handle the edge cases, we are going to create this dummy head and tail nodes. Okay, so now when we increment a key, we first check if it exists in the hash map. Okay, if the key is new, we look at the node after the dummy head. If that node doesn't have a frequency of 1, we are going to create a new node for frequency 1. We add the key to this node and update the hash map. Okay, so see, initially we have one head and one tail. So after head I will check the frequency. If that frequency is not there, then I'm going to create a new node with that particular frequency. Okay, initially it is going to be frequency 1 only, right? If I'm adding a new key and that is not there, so initially count is going to be 1 only, and then in that one I am going to add the key. So in the one, let's say I have added lead as my key in the front. We add the key to this node and update the hash map. If the key already exists, okay, we are going to find its current frequency node and check the next node, okay, which shows the next higher frequency. So here I was incrementing lead, but this lead was already there here, right? So I am just going to look for the frequency of this lead first, okay, this node first, and then later on I have to increase this frequency now. So this is what I am saying here. Okay, if the key already exists, we find its current frequency node and check the next node, which shows the next higher frequency. If that next node is the tail or doesn't have the expected frequency, then we are going to create a new node with the increased frequency, right? We then move the key to the right node, remove it from the old node and delete the old node if it becomes empty. Okay, so we are moving this to here, and then when it becomes empty we are removing it. This is the simple thing that I'm saying here, right? Done. Now what is going to happen when we decrement a key? When we decrement a key, we first check if it is in the hash map. If it is, we remove it from its current node. Definitely we are going to remove it from its current node because we are decreasing the frequency of this one. If the key's frequency is greater than 1, we check the previous node. If needed, we create a new node for the decreased frequency and add the key to the appropriate previous node, updating the hash map. If the frequency is 1, we remove the key from the hash map completely. Okay, so from 3 I will move back to 2 now. If 2 is not there, then I have to create it, right? But if it 1 initially, then after that it is going to become 0, then we have to simply remove it and delete it. Why we need to maintain the count 0? So if the frequency is 1, we remove the key from the hash map completely. That's it. Okay. to find the key with the maximum frequency, we return one of the keys with the we return one of the keys from the last node in the list. Definitely we are storing them in increasing order, right? For the minimum frequency key, we get the key from the first node after the dummy head, right? If there are no keys, we return an empty string. Okay, so I hope that you guys are clear with this statement. Okay, so now how our algorithm is going to work, let's see that. So first we are going to create one node, right? And each node is going to contain the frequency of the key, and prev is going to be a pointer to the previous node, and next is going to be a pointer to the next node, and keys is a set of strings representing the keys with this frequency. Okay, then the constructor is going to initialize the frequency and sets prev and next to null pointer. Okay, and then there is one class. It is going to create a dummy head node and a dummy tail node, and we are going to just link the dummy head to the dummy tail and vice versa. Okay, so let's first write the code for this part only. Okay, then I'm going to explain this incrementing a key inc function. Okay, this one. So let's first write the code for this one. Okay, so come here, let's just increment the size. Okay, now inside this, what we need to do here. Okay, so here first we need to create one class node. Okay, so let's do that. So here write public class and then node. Okay, and in this node we are going to have frequency prev next and keys. Okay, so here int frequency node prev node next, and keys is going to be a set of strings representing the keys with frequency. Okay, set of strings representing keys, right? So new hash set. This is done. Then after that, the constructor initializes the frequency and sets prev and next to null pointer. Okay, so just do one thing here. Then write node. Okay, constructor we are creating, right? In this we are just going to pass frequency. Let's say int frequency, and I'm just going to set this dot frequency is equal to frequency. That's it. And now in my class all1, here I have to create two nodes, head and one tail, and after that here let's create one map of string and node. Okay, so here let's name it map. So this is what's happening here now. So this is my map, this is my key, and this is my value. Value is nothing but node, right? So key is a string, so this is my key algorithm, and node is nothing but value, that is nothing but one and algorithm. Okay, so this is what I'm doing. Map new hash map. Done. Then in all1, okay, here I am going to say that let's create one head is nothing but initialize it, new node, it's a new node, and value let's say 0. Okay, same way for tail, new node 0, and then I am going to say that point my head dot next is going to point to tail, and tail dot prev is going to point to head. Okay, so here tail dot prev is going to point to head. Done. So this is what we need to do. Okay, so now let's see what we need to write here inside this public void inc string key. Okay, so here in this, if the key already exists, okay, then we have to retrieve the corresponding node from the map, right? And then we have to erase the key from the current node, and then we have to check the next node. If it doesn't exist or its frequency is not frequency plus 1, then we have to create a new node with the frequency plus 1, insert the key into this new node, link the new node with the current and the next nodes, then update the map to point to the next node. Otherwise, insert the keys into the existing node. Okay, so let's first write the code for this one. Okay, if the key already exists. Okay, so here let's write if my map dot contains that particular key now, so contains key and here pass key. Okay, so now if it contains key, then what we need to do, then write node is equal to map dot get key. Okay, so now I'm just going to get the value of that particular key. Okay, so let's say here I want to increment lead, then for this lead I'm going to search. Okay, I'm doing map dot get this lead. Okay, I have to increment this. So for this lead I will get this value now here in my node. Okay, in this node I will get that value. So now I need the frequency. So how I'm going to get the frequency? So frequency is equal to, for this particular node which I retrieve here, for this I need the frequency. Okay, so node dot frequency. Easy, right? And now after that we have to remove this key, right? So node dot keys dot remove. Okay, we have to remove this key. Okay, this is done. Now why we need to remove this? Because I have to increment the count now. So from here I have to remove it. Okay, so here I have to write node dot keys. Okay, node dot keys dot remove. Okay, so from this set of strings. Okay, so here this is written like this na, 2 and then lead. Okay, this is nothing but my set of strings, so I have to remove this na, because there can be multiple, so I have to remove that particular one first, right? So this is what I'm doing here. Okay, removed it. Okay, then here I'm just going to check node next node is equal to node dot next. So I will just check the node dot next. Okay, I will just check this one. Okay, okay, all right, node dot next. Now what here I need to see? So here I will see if my next node is equal to tail. Okay, or my next node dot frequency is not equal to frequency which was initially there and the plus 1. Okay, because I am incrementing the frequency now. So this is what I am checking here. Okay, here if the key already exists, we have to retrieve the node from the map. We did this. We have to erase the key from the current node. We did this. Check the next node. We are checking the next node. If it doesn't exist or if its frequency is not frequency plus 1, then what we need to do? Okay, so this is what I'm going to write now. So here create a new node, new node. Okay, so now we need with one more frequency, right? So here I'm just going to do new node, and here inside this I'm to write frequency plus 1. Okay, so this is what I'm creating now if that frequency is not there. So I have implemented that frequency. Okay, now here I will see if a new, okay, in this new node, okay, dot keys. Okay, so this is nothing but set of strings now. This is nothing but set of strings I have. Okay, so here I've created one set of strings representing the keys with this frequency. Okay, so this is what I'm going to do. New node dot keys dot add, set operation, keys dot add, right? In this I'm going to add this particular key. Done. I've added this key. Now this new node prev is going to point to my previous node. Okay, previous node. Okay, and new node dot next is going to point to my next node. Okay, and node.next is going to point to the new node, right? And next node.priv is also going to point to the new node. I'm just making the connections here, right? And then once all this is done, then we have to just update my map.put, and in the map I'm just going to add this particular key and new node. Okay, now it is referencing to new node. That's it. In the else part, here I'm checking if that frequency is already there. Then in that frequency only I have to add that key, right? Next node dot keys dot add key. Okay, if so, this is what happening here, right? Increment lead, so 4 was already there, so in this 4 I was adding this lead now, so this is the operation for that one. Okay, and then map dot put. Okay, so we have to put this key and we have to just reference it to next node, right? So this is what I'm doing here, right? So 4 was already there, so I have added this lead in this 4. Okay, and then this lead is going to point to this next node. Okay, this is done, and here it was pointing to new node if it was not there, if that frequency is not there. Okay, so two different things, right? Here I have explained. So if that frequency is not there, then we have to create a new node, and then we have to point that our map to that particular new node. If that frequency is already there, then I have to just point my map to the next node. Okay, now here next line, if the current node has no keys left, remove it. Okay, so here I will check now. So I have to remove this red color box, right? No keys left for this red color box, so I have to remove it, right? There is nothing here. So here I'm just going to write if node dot keys dot is empty, then in that case remove node, and here just pass that particular node. Okay, this is done. I will write the code for this remove node later on. Okay, but just understand what I'm doing here, right? This is done. Okay, now after this, so here this ends here and this was going to end here. Okay, if my map contains that key. Now in the else part we need to write. Okay, so in the else part what we need to do, so here let's read it. If the key doesn't exist, then we have to check the first node after the head. If it doesn't exist or its frequency is greater than 1, then definitely we have to create a new node with frequency 1, insert the key into this new node and link this new node with the head and the first node. Otherwise we have to insert the keys into the first node. Okay, so easy, right? So here just write else node first node is equal to head dot next, and here I'm just going to check if my first node is equal to tail or first node dot frequency is greater than 1, then in that case we have to create a new node. Okay, with the frequency just 1. So here I'm just going to create a new node, and here I'm passing the key as 1, right? And new node dot keys dot add key. Okay, this is a value that I'm adding here, this key as a value. Okay, in that particular key. Okay, and then my new node dot priv is going to point to the head, and my new node dot next is going to point to the first node, right? And my head dot next is also going to point to new node, right? And first node dot priv is going to point to new node. And now in the map I have to do this map dot put key and here I have to just write new node. Okay, this is done. And in the else part, what we need to do, okay, so if we have already one key with the one node with the key as 1, okay, so first node dot keys dot add key, and now just update the map now. Map dot put key as first node. Okay, so easy now. So we are done with this increment function. So some lines of code are there definitely, but yeah, that's it. So that's it for this increment. Okay, so here this ends. Okay, increment function. Now after that we have to write the code for this decrement. Okay, but I hope that you guys are clear with this, how this is working. Simple, these lines, right? These lines, right? Now let's see how we are going to decrement the key. Okay, so if the key doesn't exist in the map, return immediately. Retrieve the node corresponding to the key. Erase the key from the current node. If the frequency is 1, remove the key from the map. Definitely we have to remove it. Otherwise, check the previous node if it doesn't exist, because we are decrementing the frequency now. So, or its frequency is not equal to frequency -1, then we have to create a new node with the frequency -1. Insert the key into the new node and link it with the current node and the previous node. Otherwise, insert the key into the existing previous node. If the node has no keys left, remove it. Okay, that's it for decrementing. Okay, so let's write the code for this one. So for this decrement, code is a little bit smaller than increment. I am saying little bit smaller, okay, not smaller, little bit smaller than increment. Okay, there is comparison here. Okay, so here just write if my map doesn't contains key, this particular key. Okay, if it is not there, then we have to simply return it. That's it, return from here. Okay, now after that, node is equal to map dot get this particular key. Okay, and now node dot keys dot remove this particular key, remove it. Okay, and now take the frequency. Int frequency is equal to node dot frequency. Okay, this is done. So here I will check now. If frequency is equal to 1, then we have to just simply remove it from map. Okay, map dot remove this particular key. Okay, and in the else part, what we need to do, take the prev node. Okay, so for prev node we need to check the frequency now. Node prev node is equal to node dot prev. Okay, and now I will check if my prev node is equal to head, okay, or prev node dot frequency is not equal to frequency -1. Okay, then in that case, node new node is equal to new node frequency -1. Okay, we need to create a new node with this key, right? And in this new node I have to add the values, right? New node dot add keys dot add, and here I have to just add that particular key. Then new node dot prev is going to point to my prev node. New dot next is going to point to node, and prev node dot next is going to point to new node. Okay, and here node.priv is going to point to new node, and just update my map.put key new node. Okay, and once this is done, then in the else part, priv node dot keys dot add that particular key, and here just update my map. So same things we are doing, right? For increment decrement, nothing much difference, right? Just what we are doing for next node, here we are doing that for priv node. That's it. Okay, so once this is done, then here I am just going to check one thing. If my node dot keys is empty, then in that case we have to just remove that particular node. That's it. Done. That's it. Okay, now we have to write the code for get max key. Okay, so this is very simple. Max key, if there are no keys, the tail's previous node points to the head, returns an empty string. Return one of the keys from the tail's previous node. That's it. So very small code for this one. So here I'm just going to write if tail dot priv is equal to head, then in that case return empty string, return empty string. Okay, this is done. Otherwise return tail dot priv, and for this priv go check the keys, and from these keys just take any one key. Iterator, you can use iterator dot next. Okay, it will just return any key, any value for that particular key. Okay, tail dot priv dot keys dot iterator dot next. That's it. Okay, and same way it is very easy for min key. If there are no keys, the head's next node points to the tail, returns an empty string. Return one of the keys from the head's next node. Okay, so just copy this. Okay, let's write it. If head dot next is equal to tail, then in that case return empty string. Otherwise return head dot next dot keys dot iterator dot next. Okay, that's it. Now we are just missing one thing, right? We have to write the code for remove node. Okay, I told you that we will write it later on, remove node. So that's it. We are done with our code. Okay, we are done with our code. Removing a node, remove node function we are going to create. We have to link the previous node to the next node and vice versa to remove the specified node from the linked list. Delete the removed node to free its memory. That's it. So here write just 2-3 lines are pending, right? That's it. Remove node, and here node priv node is equal to node dot priv node next node is equal to node dot next, and priv node dot next is equal to next node. Okay, so let's correct it, and here next node dot next is equal to priv node. Okay, so we need to write priv now. Why I'm writing the next? Otherwise, okay, it should be priv. Now let's run it. So all the test cases has been accepted. Now submit it, and I hope that there are no code issues. So wonderful, right? So all the test cases has been accepted, and our solution is accepted as well. Okay, so let's go over the time complexity. The increment and decrement methods both perform operations that are constant time. So in increment, whether inserting a new key or updating an existing key, the operations primarily involve updating pointers in the linked list and updating the hash map, which are of one operation. Similarly, in decrement, removing a key, updating the hash map, and possibly creating a new node or modifying the previous node also takes the constant time. Therefore, both operations run in O1. The getMax key and getMin key methods run a key from the front or back of the linked list, which is also O1 since it involves accessing the first and or last element of the list. Okay, so overall time complexity is O1 for all the operations. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.